Good afternoon, everyone. Thank you so much for joining us. My name is Desmond Martin. I'm the Chief Learning Officer at NextWaveSTEM, and this is another one of our free webinar series. Today, I have the very good pleasure of having a special guest with us, Scott Weiler. He is an aerospace engineering educator from Nevada. I'll get a chance to introduce Scott a little bit more in the near future. But I'm really, really excited to have each and every one of you with us. Today, we will be discussing integrating drones in the classroom, STEM with a future, with a focus on the future of mobility and doing that learning remotely. Really, really interesting, almost nerdy kind of a situation. But I'm excited to have you all and our guests with us today. I know that we have Scott with us as well. Scott, you're troubleshooting your camera. We're working to make sure that you can get your camera open on the back end. While we are working on that, I will take a little bit of a moment to go through just some basic ground rules that we have for our webinar today and some housekeeping notes as well. The first is that we are indeed in webinar mode. That means that we won't be able to hear you and we won't be able to see your beautiful face, even though we know that you have amazing speaking voices, that you have been perfectly camera ready and able to join us, and that you have the perfect zoomable background. We know you're definitely in order, but unfortunately you won't be able to see any of that. That does not mean, however, that you're completely voiceless. Our chat is open, so is our Q&A functionality inside of Zoom. That means that if at any point you have any questions, any comments, anything that you wanted to go back over, or if you just need me to slow down, you can absolutely jump into the chat and let us know. The second piece of information that is useful for you to know is that we will be recording today's session. That means that if you have to drop off, or if you just want to share this with a colleague, you will have a link to the YouTube page where this recording lives. So we just want to make sure that you're aware of that at all. And if at any point you have any questions about what we do in NextWaveSTEM and you want to get to know more about us, you can always check us out at nextwavestem.com and also on our social media. Oh, we have another awesome guest with us as well. I want to give a shout out to Dave Erath at Drone Blocks. Dave is awesome. He's one of our really trusted colleagues. Hey, Dave, thanks so much for taking the time to join us. We'll be talking actually quite briefly about what Drone Blocks does and how they can also help empower your classroom. So Dave, thanks so much for joining us. With that being said, we will go right on ahead and dig right in. Before I do that though, I just want to do a quick sound check. Scott, can you at least speak with us? Do we have you?
I think so. I think I got speaking, and hopefully we'll get the camera activated here in just a second.
Awesome. We'll keep working on that camera for you in the background, and we'll try to get that camera going for you as quick as we can. But with that being said, we will roll right into it. A great place to begin really is at the beginning, and that's to share a little bit more with you all about NextWaveSTEM and what we do. Without focusing too much on what you see about us on the slide in front of you, NextWaveSTEM is a STEM education startup. We are founded proudly in Chicago, Illinois, and we have been around for just about 3 years now, serving mainly Chicagoland students in emerging technologies. The reason why we love working with students and working with teachers, the reason why we have a focus on emerging technologies is, frankly, we believe that there are huge problems that we cannot overcome unless we employ some really innovative, ingenious, cutting-edge technological solutions. Global warming is real. It's here. We've seen global warming's effect on our neighbors. If we think about what's been going on in Texas and some other parts of the United States, climate refugees are here in the United States. And that's that major existential threat, but there are much smaller, more localized, just as important problems that we face. Problems like food scarcity and potable water, having safe drinking water, even something as localized as what we deal with here in Chicago, just having way, way too much traffic to contend with. All of these major issues are things that we want to be able to empower the next generation of learners to solve. And we believe that emerging technologies like drones, robotics, artificial intelligence, and 3D printing will hold some of the keys to that solution. So we developed a tool, not just a tool, but a system of tools in our courses that not only empower students with emerging technologies, but also empower educators. We provide an all-in-one solution where educators can get access to the curriculum they need, the equipment that they need, and the training that they need to really have effective outcomes in the classroom. Just to speak briefly to what that looks like, those once again are in our 3 technological areas, what we call our hard earthbound technologies and robotics and AI, our skyward technologies with drones, and our manufacturing technologies with 3D printing, covering grades K through 12. And as I mentioned before, these are licensable courses that align with NGSS, varying engineering technology standards, Common Core Math, and ELA, while also strengthening 21st century skills. We'll talk a little bit more specifically about that later on, but that's just a little taste of what we do. Now, to introduce you to our guest, I have with me our speaker today, Scott Weiler. And I'm a big fan of Scott's bio. He's awesome. Scott teaches aerospace engineering at Rancho High School in Las Vegas and a dual enrollment engineering program for high school students at UNLV. In the past 12 years, he has taught in 2 countries, the United States and Korea, from students pre-K all the way collegiately. He coaches the engineering club, MESA, and the Catapult team, robotics, that's working with FIRST Robotics and VEX Robotics as well. The RPG club, he's a gamer, which I absolutely love, and Interact. One of his passion projects is to get more girls interested in STEM, and he founded a group, Girl Power in Science and Engineering, while he was in Tucson, Arizona. He worked for Paragon Space and Development on the Orion capsule and the Mars project with ECLSS, ECLSS. So we have an actual NASA contractor here, someone who is doing amazing things, and a litany of awards behind his name, including the 2015 Southern Arizona Engineering Educator of the Year, the 2015 Excellence in K-12 STEM Education, 2016 Raytheon Excellence Awards, 2016 Cox STEM Teacher Techie Award, the 2016 Honeywell Educator Award, 2016 Henry Ford Teacher Innovator Award, and the 2017 ITEA Teacher Excellence Award. If I went through all of Scott's accolades, we would be here for the next hour. Just suffice it to say, Scott is an awesome, awesome guy who can really speak to the efficacy of aerospace engineering in the education for our middle school, high school, and collegiate students. Scott, I said so much. I want to turn it over to you to say what you would like to say.
Well, I thank you very much. You went further on my bio than I had intended. I appreciate it. I'm very excited about what we're doing here today, and I welcome all of our guests in the chat or in the program, our attendees today, because I think when we're talking about drone technology, there is so much potential in our future for where this can go in such positive ways. And I'm very excited to hear what you say and tell you where current education stands with it and where we can definitely be going.
Awesome. Thank you so much, Scott, for your presence with us and just for the expertise we know you will bring. So we'll jump right into it, kind of setting some expectations for what's going to happen on our webinar. The first is that we want to consider some of the ways that novice and advanced students will learn about computer science using drones. We focus on computer science in particular with our own coursework, but we want to think about more integratedly throughout the landscape of aerospace engineering and aerospace learning, just a little bit of how important it will be to build up our CS skills as we're looking to fill some of those jobs and solve those larger societal problems. But then we'll also explore the connection between what we're doing in NextWaveSTEM courses in the real world of drone application. How do we take what your students are learning in the classroom and combine that to the next leap for what they will be doing in industry and college and even career readiness. Once again, that chat is open. So if you've got any questions or you want to make any comments, we're going to make sure that we leave a Q&A section towards the end. But we're going to have the opportunity to really pick Scott's brain. So if you've got questions for Scott during the middle of the webinar, feel free to drop them in the chat as we go. So an awesome place to begin is with a definition. I tell the story often that as an undergraduate, I had an elective course that I took with a really awesome professor. And the first thing he said to me was that you will always know a bad presentation if they begin with a definition. Well, since we are 7 slides in and now we're just only now getting to a definition, hopefully that means this presentation is only 1/7 as bad as it might end up being. When we think about a drone, what a drone actually is, I always like to bring up the Oxford English definition for drone because that word entered into our lexicon pretty late. The last time or I should say the first time that people started using the word drone in really high occurrences where it wasn't something that was kind of archaic was about 2001. And it was about 2001 because we heard the word drone at the news more and more and more as they were being deployed for military uses after 9/11. Oxford defines a drone as a remote controlled pilotless aircraft or missile. An unmanned aerial vehicle, not to be confused with a UFO, an unidentified flying object. We're talking about UAVs. That's another term you may have heard quite often. But really, in a lot of ways, we can even distill what a drone is further by thinking about what a drone does. So I have 3 bullet points that really simplify, make it super crude, if I can say it that way, but try to get to the brass tacks of what a drone is. Generally speaking, this is not in all cases, but generally speaking, a drone uses sensors to follow a simple directive, which is to go from point A to point B. The directive is simple. Getting from point A to point B may not be so simple depending on our environment, but the directive is go from point A to point B. Drones can be piloted remotely. If we think about as we were growing up as children, piloting RC cars or piloting RC aircraft, but they can also be piloted autonomously through software. Computer code telling our drone what to do so that we don't have to. And that can even happen in concert, where part of what the drone does is what we're commanding it to do, while the drone is also making some adjustments using computer code. Drones that are piloted autonomously can also fly according to predetermined paths, thanks to global positioning systems. GPS has made a huge difference in the ways in which drones are used. And drones can range in size, equipment, and ability. You can find drones commercially available that are about the size of a small dinner plate or much smaller than that. Or you can find some drones that are the size of traditional aircraft and much, much larger. So when we think about drones and what they are, it's also really useful to think about what drones do. And I love highlighting this because What we're attempting to do is get away from our preconceived notions about drone technology just being focused on some really specific application, understanding that it's diversifying. Scott, you've worked at NASA, so you know really well the ways in which drone technology is being used to explore space. But we're also seeing drones being used more and more often in agricultural purposes to monitor traffic, parcel delivery, something we'll talk about a little bit later on, even micrometeorology. There are some new stations who have been able to replace their helicopters, or even if they didn't have helicopters to begin with, use drones in lieu of helicopters to do micro reporting. And there are even a couple of startups that are using drones to help fight fires and for public safety purposes. This is, once again, a really, really short list of the different ways in which drones are being used. So when we think about drones, they're doing all these different things, and we can think about them as doing two things that are really awesome if we had to categorize them. Drones are making the world much smaller and operating in smaller and smaller spaces. We're seeing drones deliver objects, vital supplies, or just our everyday needs and wants via drone delivery. I know I mentioned Amazon, but there are a couple other startups and even larger organizations like UPS and the federal mail system are experimenting with drone delivery. Things like internal and exterior security, but I keep going back to this because it really touches my heart. We're making the solar system smaller too. Just a couple of weeks ago, we saw the Perseverance lander actually touch down on Mars after a multi-month mission on one of the fastest rockets we've ever made. And that's amazing because it's just not one platform up there, but a second. The Ingenuity Mars copter is going to be the first flying machine that we put on another planet, navigating the Martian atmosphere. It's an autonomous drone, millions and millions of miles away from the Earth. And in the course of 130 years, we went from not having powered flight at all to flying things on other planets. And frankly, that blows my mind every time I think about it. That's two 65-year-old grandmas living and passing away back to back. That's how short a time that was. That's incredible to me. So that's where we are currently, going from this place where this technology was really niche and really hobbyish to really being on the front end, the pinnacle of the kind of things that we could see students doing in the future to explore and solve some really, really big problems. So I've done a lot of talking, but I want to kind of turn it over because what we want to get a sense for is what is the pathway for our students. We understand how important this technology is. We understand how vital it will be for the future. We understand not only just the purely cool stuff that's happening, but the kind of massive impacts that could happen for society as a whole through scientific discovery, thanks to drone technology. What's the pathway for our students to get involved? And this is where I kind of want to pick Scott's brain a little bit. And we're going to start off with a little bit of an interview style here. So Scott, to turn it over to you, how would you perceive the growth opportunities for students who are in career and technical education pathways into drones and to drone adjacent industries?
Well, school districts and even schools in general, if they're, a lot of them are already adopting active robotics programs. And there is tons of series of robotic curriculum out there that we can use, you know, and robotics in general, VEX, Lego has still got a robotics curriculum. So we're starting, you know, that has already got a foothold into our education. So the next step is robotics in flight, which is drones. My school actually has an active drone class that students can learn about drones. They build them, they test them, they fly them, and they utilize them in a variety of different ways. And we talk about the career paths, because as all good CTE education should, not just saying this is what you do, but this is where it can go, and show students what they can earn from that. Because drone technology is still relatively new, everything's wide open right now. Not only is there careers that exist, such as video filming, you know, there's mapping technologies we saw in one of the images. And you're absolutely right, agriculture loves drones, because instead of the old-fashioned crop duster coming through and having to be high enough not to crash, but a lot of those chemicals go all over the place. A drone can be literally inches away from the crop and spray directly to it, instead of having the chemicals go into the soil or into the neighboring areas around it. The mapping technology that's come around with it is outstanding. If students know that they have these possibilities for career paths in something that they could really enjoy, they are definitely much more interested in going that path. So we give them the foundation of what the drone technology is, and then show them where they can do it. Las Vegas has a school for learning how to fly drones commercially, where you can get your FAA license to do so. So we are at the tip of the iceberg when it comes to where drone technology is going to go, and what education can do to make it a part of our educational system.
That's really, really interesting to hear that we're still at the tip of the iceberg. And the reason why I say that is, in a lot of ways, when we don't have a lot of depth of knowledge of the field, and we see an explosion overnight, there seems to be kind of like this dichotomy for a lot of us in our understanding. Either this is something that's super nerdy, and I have to be completely technical, and I have to be a professional who studies STEM and has a STEM degree in order to understand what's going on, or I'm that person who's all gung ho to learn something new. Hey, where are the opportunities at? Is that true, or do we see kind of like a middle ground where there's a middling perception of the future for drones?
Well, in all honesty, I mean, drones are inherently, at this moment, inherently nerdy. When the car was invented, you had autophiles coming out, and it was, you know, it was their STEM, it was their nerdy moment. But now cars are everywhere. Every person can have a car, different types of cars, different things, different means of usage. Drones right now, they've broken the expensive barrier. You can go down and get, you know, a $10 drone right now and play with it. It's a toy. Kids can literally play with drones. So we've broken that barrier. And the next one is making them, you know, everywhere. We just see them. They're part of our existence. We make it accessible to everybody. So in the future careers, it does not take the STEM-centric or the nerdy kids to be a part of this future. It is waiting for the entrepreneurs and those people who are willing to push the technology forward that exists, not as the technology itself, but as the applications of it. It didn't take a nerdy person to think of, wait a minute, I have a drone here. I bet you could deliver a package. It took Amazon to say, how could we do it with thousands of them at a time in big city and urban environments where ground vehicles have a hard time getting around? We can alleviate some of that. So no, it does not take the STEM-centric to do it. But I think more than just the applications of it, one of the bigger areas are going to be development of new drones. So as people are coming up with new ideas, yeah, you're going to need the STEM people who can know what the technology is and how to build it and engineer new stuff. You're going to need people who can maintain it. You're going to have the technical people, not necessarily college educated, but technical schools knowing how to fix the drones that are out there. And piloting, that'll be much more everybody, but we're going to have people who can teach it and know how to do it to a professional level to expand the number of people that can do it. So right now, school doesn't necessarily have to make it a STEM course as much as an awareness course of what it is and what we could be doing with it.
That is a really powerful point when you think about the technology ecosystem. I love that analogy you made there when we think about the automobile. I'm originally from Detroit, so I'm kind of steeped in that ethos and the lore of an industrialized America, in large part that was fueled by the automobile, but also automobile infrastructures. And it'll be really exciting to think about what future infrastructure looks like as it's been empowered by drones. But that's a perfect segue when you mention being able to get past that price barrier where so many more students or really students of all ages are able to participate with drones. Do you think then that there is some kind of break in the pipeline where even though there's a barrier for entry that's now lower than ever before, we hear these persistent reports about STEM fields not being populated with enough qualified personnel? So is there kind of a disconnect between the low barrier of entry when you think about droning, or in kind of that end goal of professional drone and drone adjacent experts?
Well, I mean, if we're going to be honest about this question, of course there's a lack because we are still facing, I'm an educator first. And the first part I say is there is a lack of equity in our education system. So until we at least address that basic premise, of course there's going to be some. But the real question I think comes from, does there need to be? And the answer is no. All people and everywhere have access and can learn the drone technology. We do not need something special to be a part of what this is about. Middle schoolers, high schoolers, every part of the United States can have access to this. Even if, we have a drone program at our school, to fly them, we can be inside of a building to practice flying until our students have the appropriate licensure to do more. That licensure is pennies that we as a school can afford to get to our students. There is no reason that anybody from any level, whether you're a STEM person or a humanities person or a technical person, could not have access to this. Like I said, drone technology is a toy. It is cheap. We do not need to be holding back because we're worried about the overall cost of it. That is a misnomer now. So we just have to have it. We just have to have an open mind about expanding it to everybody. So, I mean, robotics, 10 years ago, robotics was only to the highest of schools, the ones with all the money and the great tax bases. Now schools everywhere, Title I schools, can have access to real robotic technology that's teaching kids real stuff. And companies are dying for people with robotics experience. I come from Nevada. Up north in Reno, we have Tesla. Tesla has the Gigafactory in Reno, Nevada, making electric cars. They have so much robotics in their factory. I got to work with them. You have an immediate starting benefit, an increase in pay if you have had any high school robotics whatsoever. So, they're ready for us. So we need to be ready to get our kids down this pipeline. And I think it's an obligation of education.
And that is super duper exciting because what we're seeing then is this real opportunity, not necessarily about any physical barrier of entry now, but more of a mindset barrier. If we can afford this, if our schools can afford it, if our tax bases can afford it, then it sounds like it's about understanding really the viability to get in there and learn real concepts that students may apply beyond just the drone industry.
Yeah. Yes.
That is an exciting future.
Absolutely.
That is an exciting future to consider, because with our times with drones, we know that the last thing our students are is bored. In fact, when we think about drone involvement, we're seeing more and more competition, going back to the idea of not necessarily the technical or the technocrat, but even the entrepreneur. We're seeing this idea of competition driving drone innovation forward. The last time that Scott and I talked, he mentioned something that I didn't know about, which was the NASA Aeronautic Design Challenge. It's actually a challenge that's been running since 2012 by NASA. In the past, it included both high school and collegiate students. For the past maybe 6 or 7 years, it's only been collegiate students. Not sure if that's going to revert back to the high school level. But these are students working to design actual solutions with NASA, as NASA's built a blueprint for the future of the entire aeronautics industry. So when we think about the ways that flying cars may play a part of our future, we've got high school students who have access to be on the very ground floor of that through drone technology. Or if they just want to have fun and compete, we've got a brand new professional sports league in the drone racing league, where their competitors flying drones at a high level, incredibly, unbelievably high level, proving some of those professional flight skills.
And the drone racing league is very well supported. Football owners are using their own stadiums to host these events. Everybody's wanting on the ground floor of this. When it starts playing on ESPN, you know that there is something to that. And for my I know I got a lot of teachers out there, and I want to say, we have these competitions, but I also want to add Vex Robotics is adding a drone competition. So for those of you in Vex, the Real World Design Challenge is always, it doesn't sound like it, but it always involves drones in its project orientation. So there is a lot more things that are becoming available for us to be competitive and drive, competition drives innovation. So there's a lot more out there coming in the next few years for educators to utilize to get their students excited about it.
That is tremendous. Okay. Well, with that being said, you are an educator first and foremost. I think the big question here is thinking about how this ties into curriculum. A big conversation that we hear about emerging technologies and STEM generally is this question about assessment, and where this fits into this broader idea of not just being able to teach these concepts, but kind of the onus that's placed upon us as educators and administrators of how we are going to prove that our students are learning, that they're acquiring skills, that they're acquiring knowledge, and that this is transferable to a higher level of learning so that they can eventually progress towards employment and towards solving these big problems. What's your take on assessment for emerging technologies or with drones? Where does this fit into that hierarchy?
As in STEM as a whole, okay, education has to stop focusing on content, which has its place, but focusing on skills. Assessment, we're talking about project-based learning, problem-based learning, challenge-based learning. All of those focus on the skills that tie in the content and say, okay, you know what you know, now how can we apply it? Drone technology will be an application-based assessment. How do you use it? Can you know? Can you build? Can you develop? Can you program? All of those are skills, and those need to be the focus of all assessments here and in the future. This will take a little bit more effort on an educator's part. Is it more fun as an educator when it's that way? Yes, because application means it's an active process versus checking off some multiple choice boxes to where we're going. So it's going to be all about applications. It's going to be about projects and showing what skills our students know more than the content that they can regurgitate for us.
That I couldn't agree with you more about. And what we hear consistently, especially from STEM educators, is that it is exactly about the skills. What can you do with the technology? What can you accomplish with these concepts? My professional background is in engineering, and engineering, for those who don't have a really nice, tidy definition, if you take those other acronyms from STEM, science, technology, mathematics, you're engineering when you take that stuff and use it to solve a problem, which is really cool, because science, technology, mathematics, they kind of exist for the sake of their existing. If you think about siloing them that way, not particularly useful, but math is its own type of science. Science we use to understand the natural world around us. Engineering is human-centric. It is about solving a problem for some people, some end users. So this idea of taking these skills and using them to do a thing, and hopefully that thing is solving a problem, at least solving more problems than it's creating, is really exciting about the kind of work that we want to do. Right. I kind of want to ping you a little bit here, Scott, because we're definitely aligned when we think about assessment and what assessment is for. Could you imagine this integration of technology into our assessment models that we have currently? Do we imagine using drones as the assessment and using the applications and the problems and projects that drones solve to also assess other content areas like reading or mathematics or social studies? Is that something that you can see being integrated that way?
More than imagine, I dream about it. That's my fantasy someday. I gotta, maybe a low bar there, but I have a real passion for hoping that it will be. Do I know how drones will be applied to reading? No, but as a teacher who's taught language skills, can I see that there might be some possibilities? Of course. One thing that was definitively lacking in a lot of English courses is good technical writing, okay? As a person who worked on writing manuals for NASA, technical writing cannot be overstressed, especially in a STEM-centric world, and we have to face that. And there is not enough technical writers right now. The humanities teachers, I'm hoping, if any of you are listening, can definitely help the world out by getting people who understand STEM, but understand how to convey knowledge in useful and practical ways for the majority of people. Because we can't just rely on engineers who have a certain way of thinking, have that job always. Or if they do have that job, they need the practice and understanding of how to be an effective writer. So as in middle school, I have had in my engineering class technical writing classes. So it wasn't drones, but it was technology. It's things that kids can use and develop. from simply saying, all right, you got to write a one-page technical manual on how to use a pencil
Right.
to convey that kind of idea. But as we grow through middle school, high school, and into college, we need to have them much more adept at writing this. So I think there's areas where, and then the humanities, social studies needs to have a technical aspect of how our technology developed historically. How, not just that Henry Ford existed, to go back to your Detroit, but how did he develop that, and how was the automobile influential in our history? The car defines America. Some people might not like that, but it is definitively a fact, because of the historical relevancy of the car. Where can we go? That needs to be addressed historically speaking. And so I think STEM and the humanities are going to be tied more and more to each other. And so I think there's some relevance to that.
That's incredible. You're giving me all kinds of ideas for the way that we can tie those ideas of historical relevancy, and really telling the story, not just of a particular technology, but how it shapes our lived world, our societies, and our systems of government. Those ideas are really important to touch on. That's an awesome point. So you mentioned your dreams a little bit. I don't know if we're gonna how deep we're gonna dig into the dreams, but I do want to dig into this idea of like the future state. And when we think about what's next, we're thinking of this overarching idea. So you are a STEM educator. You're an aeronautics educator for many years now, and an effective one. This carte blanche. Let's say that you didn't have any restrictions on budget or materials, and you wanted to develop a course. It can be about drones or another technology. What would that course look like, and why would it look that way?
Like I said, to give you perspective, Rancho High School is a CTE high school, and we have an aviation program. So not only myself as a aerospace engineering teacher, we have a pilot teacher. Our students can get their pilot's license before they graduate. We have an aircraft maintenance, which sets them on the ground floor to go become a certified aircraft mechanic. There is not enough people doing those jobs. They're desperate. They're reaching to the high schools to get this pipeline started. That pipeline needs to include an active and useful robotics program. We have a drone class. Our programs are 4 years. Students need to come in and say, for 4 years, I'm going to study robotics and drone technology. Not because, one's better than the other, but because a firm foundation in both makes them more effective when they get out into the market. I don't say that my students who take my aerospace engineering are only going to be aerospace engineers. I teach them the mechanical, the electrical, even some civil, so that when they get out, they're looking at colleges or they're looking at technical schools, they say, I know this, I like this part, this fits me. And I'm going to move forward with that. My students might, in a drone curriculum might say, I know, how robotics is going to work in a manufacturing sense. That's where I want to go. I'm going to go to a technical school. I'm going to go to Tesla, and I'm going to go to the Ford plant. Anywhere. There are so much factories, and they're going to be there working the robotics angle. Or they might say, yes, I love the drones. That was my favorite part. I'm going to get a career in drones. And we have a community college with a 2-year drone program already. So we got the next step in our pipeline. So it isn't, I would love, if there was no restrictions on budget or anything, I would have it decked out top to bottom, and we wouldn't manufacture drones from the get-go. But here's the beautiful part, right? And in all honesty, the dream isn't about needing so much as being able to utilize what already exists. Ethically, it is a barrier to overcome, not because it's so expensive, but because districts and schools have a limited ability to see where it can go, and wanting to invest money in that direction. Because I mean, yes, it takes some budget, and schools are strapped and tight with that right now. No fault of a lot, but we don't have to think over the moon to get to this area where we could start building this pipeline. And it will turn around and it will be self-sufficient. In any STEM field, if you get more people into STEM, they're getting the better paying jobs. It builds an economy in communities. All of that turns communities around. They provide a better tax base. Schools get more money. That there is a proof in there. I will show you the articles. This is not conjecture. This is provable fact. So we just need to get this pipeline going, and we could start simply, building classes, building programs, building a pipeline.
That's amazing, because what I'm hearing is like two things just leaping out from your answer there. That the STEM education for students here should be diverse in the focus, diverse in technologies, drones, robotics, whatever else hands-on that they can really jump into, but also longitudinal, that we shouldn't think of it as kind of the dessert portion that we set off to the side, but really integral to what our students do in the classroom as a part of their education. That's an awesome idea. I think that's a really awesome approach that we would like to help foster, and to know that the barrier for entry, once again, administratively, district level, is not insurmountable. It's something that we can do today. We got a question in there from the chat about NextWaveSTEM. Are we a partner with Cognitive STEM Certificate for Schools? We are not currently, but that's something that we are certainly looking into. We were talking about the future state. The future state of NextWaveSTEM and cognitive certification is something that we're really hopeful for as we continue to work and serve educators and students. Thanks so much for that question. It was a really good one. Just being a little mindful of time, we want to make sure that we leave time for Q&A. I got a final question for you, Scott, something that I mentioned kind of at the top, but really didn't dig into so much. Is this idea of computer science. We've heard for the last 10, 15 years that the future is code, that the world will be built on code. How important do you think that computer science is going to be for students as they pursue aerospace education and aerospace adjacent employment in the future? Is the future code when we think about aeronautics?
The short answer, absolutely. It's going to be essential. I don't think in the future engineers will go forward without some basic coding ability, whether it be Python or C. That is going to be a necessity, and I think high schools and middle schools around the world are seeing that tie-in. Now, for aerospace education as a whole, well, yes, I mean, look at, again, we'll tie back to the car. We've been driving cars for ages, but what's the next step? Self-driving cars. You showed at the top slide a little car that has a quadcopter, comes in, attaches, turns that car into a vehicle. But in vehicles like that, and the autonomous quadcopter type vehicles that they're developing right now, all of them have autonomous driving capabilities. You say where you want to go, and it will pick you up and fly you there. It does not require any usage of a stick or flying ability ahead of time, because that extra pilot and gear to flying the machine is excessive weight that does not help get you from point A to B. So coding, developing into AI systems, programming robotics to do anything, that is going to be essential. Building products with computers in mind is even more important. So even if you aren't the coding engineer, having an understanding of what coding takes to make a product work is one of those criteria. I beat criteria and constraints into my students' understanding, because it is a criteria. You have to be able to show how things are programmed to be able to function, and keeping those things in mind.
That is something that I think is so integral that you said when you talk not only about criteria and constraints. Let's be realistic. Let's be factual with the students about what it's going to take to move forward in the industry, but also the importance of knowing what's next, understanding that so much of the physical work that we do, I even think about actual manufacturing. I mentioned that 3D printing is something we do at NextWaveSTEM, and the idea that artificial intelligence helping us generate manufactured parts. If we're thinking about building the next generation of drones or even spacecraft, that is something that cannot be done without a robust understanding of computer science. And that's something that we really embrace at NextWaveSTEM. In our courses, we embrace block-based coding. This is where I give a huge shout out to our partnership with Drone Blocks. Check them out at droneblocks.io. I would absolutely have it take the Pepsi challenge with any other drone programming platform out there. And the great thing is that it actually connects to a physical drone, the Tello EDU drone from DJI. And kind of a running theme here is that you don't have to be a super technocrat. You don't have to know how to be a good typist, let alone be a really proficient coder to code a drone in a virtual environment or a real flying drone using block-based coding. And there, of course, is that step up, that next layer of the pipeline, where you can use something like Drone Blocks code, where students are learning some more robust coding programming languages like JavaScript. This becomes a way to work with hard hands-on technology while students are learning a programming language that's used in 97.1% of all websites on the internet. So for us, this idea of enhancing our students' computer science skills while they're building their other engineering and problem-solving skills is critical.
Right.
So here's the overarching idea. How can we help at NextWaveSTEM? I mentioned this at the top a little bit. The first is through our courses. We have an all-in-one solution for you. That's robotics, that is drones, and that's 3D printing with artificial intelligence at the 9 through 12 level. Courses that are curricula, training, and equipment. So you can go from literally scratch into having a built-out experience for your students, no matter their experience level or age and grade level as they jump into STEM with your programs. Something that's really important to think about is the idea that we're structuring our courses that follow a meaningful progression of knowledge. Students will go from just being introduced to technology in the K through 12 to discovering more about what that technology is and what it does, exploring the finer nuances, and then in the 9 through 12, just a really meaningful pedagogical progression where they're creating and evaluating the solutions that they're making with their technologies. And it's really designed to be turnkey. We're talking 10 to 15 lessons per course with virtual lesson plans as well, because we understand that we, at this particular time, are living in a space where our students have to be away from our physical classrooms, but we have solutions that work both in person and remote for learning. The equipment is available once again, and we are providing customized professional development, additional equipment, certification for course completion as well. The goal is to provide you solutions that work really well in person and remotely so that you can get your students right into that pipeline where they can get into these industries and really affect real world change. So we're sprinting quickly to the end, but we finished with 5 minutes left in the hour. So I want to provide just a couple of moments. If you have any questions for Scott or for myself about NextWaveSTEM or about drones or computer science or about anything really, we'd love to hang on the line for you just a bit and answer those questions. We've already had a really good question there before about Cognia.
What brand of drones would you buy? What drones are you using for NextWaveSTEM? I can't recall.
NextWaveSTEM, we are using the Tello EDU drone. That's a DJI product, smallish, really education-focused drone that we love using. DJI represents a huge section of the drone market, and they've been making a really reliable product for years. I'll drop that name in the chat as well. That is the Tello drone by DJI. And with NextWaveSTEM, we actually sell kits, packages for these drones. So if you're looking to outfit a classroom with drones or check out the curricula that goes with that, we can definitely get you pointed in the right direction.
I've used Flybricks for middle schoolers because middle schoolers still can love Legos, and being able to be a little creative with it is always kind of nice as well. But the brand isn't as important. I mean, DJI is a solid brand name in drone technology, so you just can't go wrong with that for durability and consistency. But find one that works for you. There's a lot of different drones out there. I bought little junker $10 drones. I get 2 or 3 years out of them, and the kids get to fly them around enough that I could put them in my classroom with a little netting or something like that to get the feel of it. But no specific brand would I say that I particularly endorse, because there's just so much out there.
Mm-hmm. That's a really good question.
I was trying to remember for people who are into drones, a product where they had a drone flying kit, but it's in a box and the drone's on a gimbal, which allows you to practice flying the drone without it having to go around a room. You can get the drone to simulate everything that you want in real life without the nastiness of it bumping into things or breaking the drone itself. So I was trying to remember that particular one with that question. So
that's something I'm going to have to check out. Ooh, really good question there. A class of freshman students who have never used drones before, wondering if getting kits to build and fly them versus buying them already built to build and fly. Scott, I think you'll be able to speak really well. What we do at NextWaveSTEM is with the drones that are already assembled. Do you have experience with drones that you built from scratch?
Our class that we offer, and I'm not the teacher of that class. I do the ground robotics first, and then but we do have a teacher that does it, and they do build that. But that class is for juniors, and it does take some electronics knowledge. So if it is a class about drones, obviously build them. If you are using it as a section of a bigger picture I would say buy the pre-built, get the pre-built ones, and then learn how to fly. Do the fun stuff from the get-go. If you want to learn how to build robots, there's tons of robotic building kits that you can work with that are on the cheap as well, that don't have nearly the real world consequences if they break. So
that is a perfect answer to that. Thanks so much, Scott. Just another question there from Luke. If we have an online store to purchase our bundles, we don't have an e-commerce store, but Luke, what I can definitely do for you is put you in touch with our sales representatives, and we can make sure that we can get an order started for you, or just figure out exactly what you need and get something tailor-made for you. We have run out of time really, really quickly. So I want to leave us with two things. First is the contact information for me. My email is really simple, desmond@nextwavestem.com. We're on all social networks, all major social networks. We haven't found our way to TikTok. I'm neither Tik nor do I talk. If we secure an intern who's much better at that than me, then maybe we'll start TikToking in the near future. But I also want to leave with gratitude, immense gratitude for Scott Weiler, who's joined us on the call today. Thank you so much for sharing your expertise. Do you have any parting words?
It's
absolutely.
really been, oh, go ahead, I'm sorry. You were being so nice, I shouldn't have stumbled over you. Thank you, and to all of you out there, again, my name is Scott Weiler. I teach in Las Vegas. Desmond can get you in contact with me. One of the things I think as an educator you have to do is be available to help other educators. So Desmond can get you in contact with me. If you have questions, you want to develop programs, you have people that you want to talk to me about developing other programs, please do, because I think we are on the precipice of developing something really exciting in our world today. That's very, that it isn't STEM as the catchphrase, but STEM as the ideology that can make the world a little bit better place. I honestly believe that. So, awesome. But thank you, Desmond.
No, thank you, Scott. We are thinking the same way. And as we follow up with everyone today, we'll be sharing the recording and the slide deck. This slide deck will be updated with Scott's information right alongside mine at the end. So you'll be able to reach out and get in contact with Scott. And we'll make sure to do a special shout out for him in that email. So if you would like to connect and learn more about developing drone programs in your schools, Scott is amenable to do that. To everyone who joined the call, thank you so much. Continue to innovate with your students, continue to explore more as you dig into STEM and create those pipelines, and continue to be safe. Everyone have a great rest of your day, and we will talk again with you soon.
Thank you all. Bye now.